Children, let's take one more sum on problems based on two-digit numbers. Now this sum is also a different one. We have taken the first one. According to me, it was quite simple. When it comes to two-digit number, we learned something that we need to write down 4 lines the moment we see two-digit number. Here also, if a certain two-digit number, so we will write down what we have stated earlier in the previous one. Let the digit in the units place be x. Let the digit in the tens place be y. Earlier also I said, if you want, you can swap the values of x and y. Therefore, the third line, the original two-digit number. What is the original two-digit number? 10y plus x. And what is the fourth line? The interchanged number. The interchanged number is 10x plus y. The interchange number is 10x plus y. This is what are the basics, and this is what we should know the moment we start with a two-digit number sum. Now children, before I proceed further, I would like to tell you one simple thing which you have again learned in your lower classes. In your lower classes, much lower classes, when you are doing division, say the question was 7 divided by 3. So your teachers must have told you 3 here, 7 here. 7 is a dividend, 3 is a divisor, 3 2s are 6, 1. 3 2s are 6, 1. This is your dividend, this is your divisor, this is your quotient, and this is your remainder. So by this time there are many who must have said the answer also from their side. What teachers used to say, dividend is equals to divisor into quotient plus remainder. Am I right? That's what you all have studied. So 7 is nothing but divisor 3 into quotient 2 plus remainder. Right children? That's what we have learned. This is what I need in this sum. So let's see how this is getting applied. But I want you to remember this technique which you all have studied in your lower classes. What is that technique? Technique is nothing but the formula, basic formula. What is that children? It is dividend is equals to divisor into quotient plus remainder. Let's read the sum now. Since we are done with the initial 4 lines, let's read the sum now. If a certain two-digit number is divided by sum of the digits, if you feel that you cannot work out directly, then always work out here. I shall use a different marker to make you all understand. If a two-digit number, so what is that two-digit number? What is that two-digit number? Two-digit number is nothing but 10y plus x. If a two-digit number is divided by sum of its digit, so what is sum of the digit? Digit in the tens place, units place. So sum of the digit is x plus y. Sum of the digit is x plus y. The quotient is 4. The quotient is 4. And the remainder, so after working, the remainder, this is not 1 mind you, after working, the remainder is 6. The remainder is 6. So can we frame our first equation? Indeed, but we'll just tell the examiner the formula which we learned right now. Using what? Using dividend. Dividend is equals to quotient into divisor plus remainder. Using this, shall we frame our first equation? S per first GC. S per first GC, given condition. What is it? Can I say dividend is equals to quotient into divisor plus remainder. Children, I hope you got it, right? We simply applied the basic formula. Dividend is quotient into divisor plus remainder, or divisor into quotient plus remainder. Meaning is the same, right? We got our first equation also expanded. 10y plus x, here it is 4x plus 4y plus 6. Bring everything on one side, constants on the other side. 10y minus 4y plus x minus 4x is equals to 6. 6y plus 6y minus 3x is equals to 6. You can see all of them are divisible by 3. Divide by 3. On dividing by 3, what will I get? 2y minus x is 2. That is minus x plus 2y is equals to 2. This is my equation number 1. This is my equation number 1. Now, we need to go with the second condition. So, what is as per the second GC? As per the second GC. As per the second GC. What is our question now saying? If the digits are interchanged, so we have the interchange number. We have the interchange number. If the digits are interchanged and the resulting number is divided by sum of the digit. So who is the resulting number now? The resulting number is no longer 10y plus x. It is 10x plus y. So let me show you here. We are into the second condition. The interchange number, which is 10x plus y, when divided by sum of the digit, again that is nothing but x plus y, because on interchanging the digits also my sum doesn't get impacted. Sum will be x plus y or y plus x. When you say that, there are many students who will say, sir, the position of x and y has swapped. Then earlier it was x plus y and now it is going to be y plus x, meaning is the same. X plus y is divided by sum of the digit. The quotient this time is 6 and the remainder is 4. The quotient this time is 6 and on solving the remainder is 4. Don't you think so? On the same lines is what we should work out. Again, we need not write down once again the same formula. We need not write down that. So we can directly frame the equation as what? 10x plus y, 10x plus y, that is dividend, is quotient into divisor plus remainder, open down the brackets, 10x plus y is equals to 6x plus 6y plus 4. Bring on one side, 10x minus y minus 6y is equals to 4. 10x minus 6x is 4x. 10x minus 6x is 4x. Plus y minus 6y minus 5y plus y minus 6y is minus 5y is equals to 4. This is my equation number 2. This is my equation number 2. Now, what is my equation number 1? Minus x plus 2y is 2. My equation number 2 is 4x minus 5y equals to 4. Which one would you like to prefer? Would you like to prefer x variable? Here it is minus x. So what is the coefficient? The coefficient is 1. What is the sign? Minus. Over there the coefficient is 4. Can I say if I multiply this by 4? If I multiply this by 4, what shall be my answer? So I shall say multiply equation 1 by 4. On doing so, minus x into 4, minus 4x, plus 2y into 4, 8y, is equals to 2 into 4, 8. This is my equation number 3. Now, what do you think so? Are they coefficients same of the variable x? Do they have opposite sign? Opposite sign means add. Adding equations 2 and 3. When I add them, 4x minus 5y is equals to 4. Again 4x but with a minus sign, plus 8y is equals to 8. When I add, gets cancels off. Plus 3y is 12. Y turns out to be 4. When y turns out to be 4, substitute y equals to 4 in equation. Which equation? 1, 2. Don't take the third one because it's a modified form. That doesn't mean that you will get a wrong answer. Unnecessarily we are multiplying by good amount of number, which is 4. I shall say equation 1 in equation 1. What is my equation number 1? Minus x plus 2y. Minus x plus 2y is equals to 2. Minus x plus 2 into 4 is 2. Minus x plus 8 is 2. Bring that over here. Minus x is minus 6. 2 minus 8 is minus 6. X turns out to be 6. Are we done with our sum? No, children. What is our answer? Original number. And the original number is nothing but the third line. 10y plus x. The original number, which is nothing but 10y plus x, which is 10 into y is 4, plus x is 6, 40 plus 6, 46 is what my original number is. What is my original number? My original number is 46. Let me cross check. Let me cross check my answer, whether we are right or wrong. What they say, in a certain two-digit number is divided by sum of the digit. So when 46 is divided by sum of the digits, means 4 plus 6. What is 4 plus 6? 10. 46 when divided by 10. Mind you, this is only for a cross check. So now whatever I'm going to do is only for cross check, children. This is not part and parcel of our solution. This is simply cross check. This is simply cross check. When 46 is divided by sum of the digit, which is 10. The quotient is 4 and the remainder is 6. We all are aware 10 fours are 40. 10 fours are 40 and the remainder is 6. Or you can go with the second also. If the interchange number, so what is the interchange number? 64. So what if 64 is getting divided by sum of the digits? Sum of the digits is again going to be, they say the quotient this time, quotient is 6 and the remainder is 4. 10 6 are 60. 10 6 are 60. The remainder is 4. 10 6 are 60 and the remainder is 4. So in either of the case, our answer is perfectly correct. Right?